Hey there, it's Jason Gorman from Codemanship with the fourth video in our series on Agile COBOL. And we've spent the first three videos looking at how we can write fast-running unit tests in COBOL. So we looked at the anatomy of a test suite in terms of test paragraphs, test fixtures, test assertions, and building test suites out of those test fixtures. And in the second video, we looked at how we can essentially dynamically replace external dependencies like the file system and databases and that kind of thing using dynamic module calls and a technique called dependency injection, where the name of the module that we're going to call is actually passed into the module that we're testing so that we can switch it with a stub or a mock. And then in the final video, we had a look at how we can parameterize our tests. So if we have multiple tests that are sort of duplicate examples, if you like, of the same rule or logic, and then we can consolidate those into what's called a parameterized test. And those parameterized tests can be adapted into what are called property-based tests or generative tests, where we actually dynamically generate the test cases in code so that we can cover a lot of cases with very little test code. And that's all very well and good if you're writing code from scratch. But most COBOL programmers are not writing new systems from scratch. They're maintaining legacy systems. So what we're going to be talking about in this video is how can we safely make changes to legacy code. And by safely, I mean with fast-running automated tests. That's very much the key to the whole thing of agility, is the ability to retest your code every time you change it very, very quickly so that you can be confident that you haven't broken it. And as we'll see as we get into later videos and we talk about practices like refactoring and in particular something called continuous delivery, those fast-running tests are going to make all the difference. So what I'm going to be doing in this video is I'm going to be outlining a sort of a set of steps, if you like, an algorithm for making safe changes to legacy code that is based on a book by Michael Feathers called Working Effectively with Legacy Code. One of the very few books, I think it's probably one of the only books on working with legacy code. It's a great book, highly recommend it. It should be on every programmer's desktop. And I'll post a link in the description below to the details of the book. Now, I'm not going to go through the whole book. This is going to be a relatively self-contained video. What I'm going to do is at a very high level with a simple example illustrate what the steps of the process that Michael outlines in his book are. So we're taking a look at some code here, some legacy code. Now this code, what it does is it reads a movie record from a file based on the IMDb idea of that movie, the unique idea of that movie. It takes the rating of the movie, the IMDb rating, and using that rating, it calculates what the rental price of that movie should be from our video library. If it's a standard movie, basically its rating is from 4 to 6.9, then we charge $3.95. That's kind of the standard price. But if its rating is greater than 7, then we say, okay, well, in that case, it's a premium movie and we add £1 to the price. But if it's less than 4, if it's a bit of a turkey, then we charge a bargain price, we knock £1 off. So that's our logic there for this price movie module that we want to test. Now, what makes this legacy code? I mean, it's pretty simple. Hopefully it's pretty easy to understand. Not a lot going on. There's a bit of complexity, we'll talk about that, but really it's pretty straightforward. And you probably think, well, it's going to be pretty easy to change this. But here's the rub. Once we've changed it, how do we know that we haven't broken the software? We'd have to retest it. And this is Michael's definition, and it's a definition that I share, of what constitutes legacy code. Legacy code is typically code that is difficult, expensive, and risky to change because of the risk that we might break it. And if we break it, the question then is how soon would we know that we've broken it? If we're relying on teams of manual testers to test our software, The answer could be weeks. It could be weeks before we find out that that change that I've just made has actually broken the software somewhere. So what we want is a suite of fast-running tests that can give us that feedback straight away, so that if we have broken it, we can fix it there and then, when it's much cheaper and simpler to do that. And that helps us to make the change quickly and safely. Now, this code has no fast-running automated tests. And that's Michael's definition of legacy code. Legacy code is code that does not have fast-running automated tests. So we can't be confident that we haven't broken it when we change it. So in his process for making changes to legacy code, let's say that we've been asked to make a change to this pricing logic, and we'll talk about that in a minute, then how can we do this safely? Well, I would want to get some fast-running tests around this code first before I make that change. So here's the process that Michael recommends. Step 1 is identify what part of the code will need to change. Michael in his book calls it the change point. So we've been asked to make a change to the pricing logic. So as well as our current bands of bargain, standard and premium, we've added a fourth band called masterpiece. If the rating of the movie is greater than 8, an example of that might be Blade Runner, for example, has a high rating, then we say that's a masterpiece, and we add another pound. So $3.95 for standard, $2.95 for bargain, $4.95 for premium, and $5.95 is considered a masterpiece on IMDb. So this code that we need to change is inside here. So this is our change point. Once we've identified the change point, the part of the software that we want to change safely, the next thing we do is we identify, okay, if this is the bit we're going to change, where would I want to put the tests to assure me that this change hasn't broken the software? So we identify the test point, or what Michael in his book calls the inflection point. And these are the modules or the interfaces that are around the code that we want to change. Not necessarily the interface of the module that contains that code. It might be a module that calls that module that we want to change. You identify the change point, or the inflection point or the test point. And Michael's advice is you're looking for interfaces that are unlikely to change, stable interfaces around which we can write tests, but behind which we can make as many changes and do as many refactorings as we like to make the code do what we want and also make the code better, more maintainable. So we identify the test point or the inflection point. Now in this case, I actually have a kind of a test harness. Let's take a look at this. So this is a program that I can run to manually test this code. And as we can see, the test harness is actually invoking our price function directly here, called price movie there. So I think I'm actually going to replace this harness with some unit tests. So my inflection point, my test point, is actually going to be the price movie module. And I'm going to write some tests for that. So step 1, identify the change point. That's in here. Step 2, identify the test point or inflection point around which we would wish to write tests. Now, before we write the tests, the third thing we need to think about is what might be getting in the way of writing fast-running unit tests. And that is normally all about dependencies, external dependencies. Now, in our price movie module here, we're actually reading the movie record from a file, from an input file called movie data. And that means that whenever we run our, in inverted commas, unit test, it will involve reading from a file, and we don't want that to happen. So the third thing we do is we identify what external dependencies are preventing us from writing fast-running unit tests for the code that we want to test. And then we need to break those dependencies. We need to turn this upside down so that we can actually use a test double. We can stub the code that returns the record so that in our tests we can say, no, I want you to return a movie with this rating. So the test decides. So step 1, identify the change point. Step 2, identify where you would want to write tests to know that the changes you've made have worked, or the refactorings you've done have not broken the code. Third, we identify the dependencies that are stopping us from unit testing the change point. And then we break those dependencies by refactoring this code so that it's possible, in this case, to use a stub to return a test record that has the IMDb rating that we require for that particular test case. Okay, now, before we do all of this, I'm just going to reassure myself, first of all, that works. So I have two habits that I get into. Before I do refactorings, particularly if I'm going to be testing things manually, which I'm going to be doing at the moment, I make sure that I've committed the code as it is. So I've got a backup that I can easily get back to. So if I'm using Git, for example, so I can reset. If it all goes horribly wrong, I can do a hard reset and revert the code back to the way it was. So make sure you've got a backup before you start doing any of this stuff. And before you do any refactorings, make sure the code is actually currently working. So I'm going to actually run my little program here. Let's run it. And we should at some point. There we go. So I can enter an ID. It doesn't matter much, but they have to match at the moment. I've got a file of 3 movies, one standard, one bargain, and one premium. Here's our standard movie, so the price should be $3.95. There we go. Oh, no, that's the premium one, yes. That's our premium movie, so the price is correct at $4.95. I use dollars for this. And let's do another one. Okay, so now let's do our standard price one, hopefully. DT 2, 3, 4, 5, 6. I used very easy to remember data here. Okay, $3.95, that's our standard movie. And then finally, our bargain basement movie, TT 3, 4, 5, 6, 7. I have, of course, invented this data. And there we go, $2.95. So I'm confident that my pricing logic is working. Excuse me. And I'm now safe, in my opinion, to proceed. Now, opinions differ on how we proceed here, but I'm super paranoid about whether or not I've broken the code. So even though I don't have fast running unit tests, I still am in the habit of retesting the code. So wherever it is I thought I would need to test, for example here for our pricing logic, I would test that manually, even if that means running an application and clicking buttons or whatever you have to do. Don't get into the habit. Don't get thinking, well, there's no test yet, so I won't bother retesting. I very much am in the habit of retesting, even if I've only got manual tests. Just got to take the pain for a little while. It will all be worth it, I promise you. Okay, now let's go back to price movie and see what's getting in the way here. What's getting in the way here is this code, which reads from the file. So what I'm going to do is I'm going to extract a new module that does this work for us. So I'm going to take price movie and I'm going to copy and paste it. Hopefully. Let's try again. Control C, Control V. There we go. And I'm going to call this read movie. So at the moment, this is a copy of price movie. Let's take a look inside. And there's a bunch of changes we need to make. It would be great if this could be automated. Read movie. So let's change the name of our module. Okay, read movie. Okay, and in our linkage section, so what we're returning in the linkage section is the movie and the IMDb ID. So I'm just going to so the IMDb, that's correct. That's fine. That's our movie. Working storage. I think we could probably get away with nothing actually. We do need the file input, and we're going to use that and our movie. So the IMDb ID is the input to this module, and the movie is the output. I shouldn't have. Let me just. This is why we back up. And that's the one that can go. Okay, so forth. So there's our file data. Exactly the same as before. But all we're doing now is reading our movie, like so. So we should end up with a movie being returned from this. Let's just compile that into a DLL. Good old GNU COBOL. It's having a little think. There we go. And now we're going to go back to Price Movie, and we're going to remove everything in Price Movie that was doing that work, and we're going to replace it with a call to read movie. So I call this refactoring extract module, where we extract part of one module into another module and replace that part with a call to this new module. So we call it with the IMDb ID and with the movie, so it's going to populate that for us. And not at all keen on that. Right, the file section can go. And our environment division can go. So we're simplifying, we're putting all the work using. There we go. So basically it's now a different module, a new module called read movie that does the work of reading it from the file. You'll see why we've done this in a moment. Now what I'm doing here is I'm trying to separate the concerns. Oh, no, didn't like that. What didn't you like? Are you still running? Let's stop running you for now. Compiler, permission denied. Oh, here we go. Here we go. Good old Windows. Ah, that's because the program was running. So that DLL was loaded into memory. So it should work now. There we go, thank you. And then if we run our program again now, it does exactly, this is the whole point of refactoring, it does exactly what it did before, and we'll evidence that with our tests. But now it does it differently. It's basically handing over the work to reading the file to another module. So we've separated that concern. Let's run this now. Cannot find entry point of Price Movie. Yes. Test price is the one we should be running. That's the program. Okay, so TT12345 is our premium one. And TT23456 is our standard one. And TT34567 is our bargain. There we go. And that's the end of the program. Right, so it's still working, and that's kind of the refactoring loop. We do a refactoring like extracting a module, and then we immediately retest any code that we think could have been broken by that refactoring, even if that means testing it manually to begin with. Our goal here is to test it automatically, of course, and once we've done that, this whole process will get a lot easier. Right, okay, so there's read movie. We don't need to make any changes to that, but the next thing we need to do is, at the moment this is hard coded, we're always referring directly to that module. What I'm going to do is I'm going to replace this with essentially a dynamic call. So let's cut that and let's call that read module, and I'm going to replace all of this read module. So this is a refactoring I call extract variable. And then in our working storage, in our linkage section, we're going to be able to have an external module or program tell it which module to use. So I'm calling this refactoring, sorry, not extract variable, extract parameter or introduce parameter. And let's make that a string. That should be plenty, and the value is read movie. Oh, no, it isn't. No, it isn't. It's not for us to say, is it, Jason? Silly Billy. So the whole idea is, let me just recompile that. The whole idea now is that our test harness will decide which one to use. In this case, I'm going to use, let's put it here. And let's call that module 30, and then there it is. So that I call extract parameter. The idea is that we introduce a parameter to a module in our linkage section essentially, and then we take the literal value that was being used originally, in this case read movie, and we pass that in as the parameter value, like that. Okay, let's recompile this. And again, we haven't made any changes to what this code does. We've just moved some stuff around. So it's logically equivalent to what we had before. And that's the whole idea of refactoring and why the tests are so very, very important, even if they're manual. Oops. Let's try again. TT 6. And finally. Now you can see how kind of hit and miss manual testing can be, which is why I don't like to rely on it for very long. And when you do rely on it, you need to be super, super disciplined. So have a test script. Let's, come on. There we go. Right. So we're kind of in a situation now where we have our price movie module that has the name of the module that it uses to read the movie record injected. And what I'm going to do next, I'm going to pause the video here and do this so you don't have to sit and watch me do this. What I'm going to do next is I'm going to write some unit tests for this, for these existing test cases, standard, bargain and premium. And that then will give me the confidence to make changes behind the scenes with the ability to retest it very, very quickly. Okay, so now I have a unit test fixture for price movie using all the techniques that we looked at in the first two videos in this series. So we have a test suite called Movie Suite that we can run. I've just run it. We have a test fixture called Price Movie Test. We have a stub implementation. Let's take a look at that. That pretends to be the thing that reads the movie records from the file. But in actual fact, all we're doing here is we're setting that data inside each test. Let's take a look here, for example, for our standard price test. We're setting our test rating to 5.5 to say this is an average movie, this is a standard movie. Okay, so same test data as before, pretty much. The same test data that was in the file that I was using, the test file. But this time it's all hard-coded and it all runs in memory, so we're not actually reading from the file. We've got our standard, our premium, and our bargain price tests there. So, step one, identify the change point. What parts of the code will need to change in order to give the business what they're asking for. Step two, identify the test points or the inflection points around which you would wish to write fast-running unit tests to reassure you that any changes you've made or any refactorings you've done haven't broken the code. So get some tests around it. Then step three, you need to break any external dependencies that are stopping you, that are getting in the way of writing those fast-running tests. So you've got to do a bit of refactoring, and that, the way I do it, usually involves some manual testing. So you have to live with that manual testing for a little while to get you to a point where you can, for example, use a stub so that you can unit test this. You can write unit tests. Then you write the unit tests and make sure those are all passing. So at this point, we've made the change we want to make potentially safe and easy. So the mantra here is make the change easy and then make the easy change. Now, before I make this change to the logic, what I'm going to do is I'm going to do this test first. So what I'm going to do is I'm going to add another test for this, which is going to fail at the moment because we have no concept in our logic of masterpiece. But I'm going to add this failing test, and then I'm going to change the logic so that all of our tests pass. Okay, so let's be naughty and do a bit of copying and pasting here just to save us some time. And there we go. Let's call it masterpiece. And the rating of this movie is going to be, let's call it 8.4. Doesn't actually matter what the IDs are now, but 4, 5, 6, 7, 8 really doesn't matter. And what we're saying is the price that we're expecting for that is $5.95. And let's just change our test name here, master. There we go, and we've gone over. There we go. So let's rejig this a little bit. There we go. Now, normally I would wrap your knuckles for copying and pasting code, but just to save time in this video, I've allowed myself to do that because it's fairly straightforward. Okay, now if we recompile this and run our test, we'll have one test that fails because the price is not going to be $5.95, it'll be $4.95. So let's run our tests. Now this is why you need to, this is a really good habit to get into, particularly if you're doing this the hard way. Make sure you see the test fail so that at the very least you know it's being run. In this case, it's not actually being invoked. So I need to add that to my main paragraph there, my main procedure. Now let's recompile and try again. So we should have one test that's failing because the price is wrong. There we go. Expected $5.95 but was $4.95. Lovely. Okay, now that we've done that, we're in a very safe position to make a change to the logic. So let's just, so we can do another one here at the bottom, for example, or maybe do it at the top. They seem to be going in descending order. So if the rating is greater than 8, we say that's a masterpiece. So we, now how are we going to do this? We add another one to the price. That's how we're going to do it. Okay, so you get a double whammy for it being more than 8 and more than 7. Okay. Now see how much easier this is now, because I'm not manually testing. I can run my test very, very quickly. Just a flick of a switch, if you like, and we find out straight away, okay, that seems to be working. Right. So we identified what code needed to change. We identified where we wanted to write unit tests, and then we identified any external dependencies in the code we want to change or around the code we want to change that stopped us from doing that. We broke those dependencies using dependency injection so that we could stub the module that returns the movie record. And then we wrote unit tests to satisfy ourselves that we had basically the equivalent of the tests that I was doing manually around our test point, around our inflection point there. Then I added a failing test that described the new thing I wanted it to do, and made sure I saw that test pass. We'll talk about that when we talk about test-driven development. So I make sure I see the test fail first, so I know it's being run and that it is a good test. Then I made the change, basically, at that point. Now, that all seems like a bit of a rigmarole, but now that I've done this, I can make all kinds of changes to Price Movie, safe in the knowledge that I can retest very, very quickly. So it's hard going to begin with. It's a bit of a pain to start with. But once you get going, once you've made that change easy by adding those unit tests, by breaking the dependencies, then the going gets much easier going forward. So, change points, test points, break the dependencies, write the tests, make the change, and then there's one final step, which is based on what we call the Boy Scout rule. Now, the rule in the Boy Scouts when they go camping is that they must leave the campsite cleaner than when they found it. So it's a similar kind of thing with legacy code. We've got all kinds of problems in our code here. Not just making the change. For example, I'm not sure now, if we take a look at our Price Movie, I'm not sure this is particularly comprehensive in terms of understanding. There's no mention anywhere in this module of bargain, standard, premium, or masterpiece, for example. So I think I could make this code simpler and more readable. And so what I'm going to do before I leave this task is I'm just going to do a little bit of cleaning up, a little bit more refactoring, just to make the code simpler, easier to understand, easier to change for the next person. And if we do that, over time what happens is the test coverage around our code starts to build up with each change that we're making. So we might begin with no tests at all, and then after a few months or a year or two of this on a large system, we tend to find that actually we've got a pretty good suite of tests now, and we're able to test maybe 70, 80, 90% of our code very, very quickly. And that means that the cost of changing the code and the risk of changing the code over time starts to come down. So the code becomes more maintainable. So we pay this kind of tax, if you like, with every change that we make to add fast-running unit tests and to do a bit of cleaning up inside, to simplify and make more readable and that kind of thing. And over time, that tax that we're paying starts to pay dividends. It's an investment, which means that code that maybe at this point is very difficult and risky to change becomes much easier and much safer to change, which means the business can have more change. They can adapt more. And if you're a bank or a supermarket or somebody relying on legacy mainframe COBOL code, that's probably going to be a good thing because that code's going to be around for a while. Now I'm just going to finish this off. I'm going to pause the video here and I'll show you the refactored version of this just to complete the process. Okay, so what I've done here is I've refactored Price Movie so that now I've introduced 88 level variables for each of the sort of levels of pricing, bargain, standard, premium, and masterpiece, so that in our code it's much clearer what each of these sort of magic numbers mean, if you like. So I've replaced those magic numbers with actual names, and that's often a good thing to do, so the code becomes self-describing in this kind of way. So the process for changing legacy code safely, let's just remind ourselves, first of all, identify which parts of the code need to change, the change points. Then identify where you would write tests around those change points, not necessarily around the exact module. It could be around modules that call those modules, because what you're looking for is interfaces that aren't going to change. They're going to be stable, if you like, behind which we can make as many changes as we need to make with refactoring and whatnot. So identify the change points, identify the test points, or as Michael calls them, the inflection points around which we want to write the tests. Then we break the dependencies that are stopping us from writing fast-running unit tests using dependency injection. And then we write the unit tests that would replace the manual tests we've been doing while we've been refactoring the code, to give us that assurance. Then we make the change that we've been asked to make, but now we can make it safely and quickly. And after we've made the change, we apply the Boy Scout rule. So while we're in that part of the code, maybe clean up a bit to make life easier for the next person. That next person might well be you, who needs to change the code. So we pay it forward, basically. And that's kind of what this process is all about. It's about making change safely, but it's also about paying it forward with more fast-running tests. As we go on, those test suites will build up, making life easier and easier. And also by cleaning up the code as we go, making it easier to understand and easier to change, so that as time goes on, it doesn't happen overnight, but as time goes on, one change after the next, the cost of changing code and the risk of changing the code goes down. And that can only be a good thing for the business. So there you go. Now we've touched on this whole topic of refactoring. In the next video, I'm going to be expanding on that, and we're going to be talking about refactoring COBOL code.